Hi, welcome to Algebra 2 Common Core. Today we're going to be learning a new kind of factoring where we're looking at the sum and difference of two perfect cubes. Let's start by going the direction of multiplying. So I'm going to multiply the binomial 2a plus 1 times the trinomial 4a squared minus 2a plus 1. I've set this up in my notes as a box multiplication. So remember how we multiplied 2a times 4a squared, and that's going to give me 8a to the third. 1 times 4a squared is 4a squared. 2a times negative 2a is negative 4a squared. 1 times negative 2a is negative 2a. 2a times 1 is 2a. And 1 times 1 is 1. Now you'll remember from a much earlier unit that when we did box multiplication, we need to look along the diagonals for common factors, for like terms. So I'm going to look first of all and see that in the case of the a cubes, I only have 8a to the third. It doesn't have any like terms. Going to my a squareds, I can look along the diagonal and see that positive 4a squared and negative 4a squared add to give me 0. Going along the next diagonal, negative 2a and positive 2a add to give me 0. So my last term in my product is going to be a positive 1. Now, this product is really important for us because we see that 8a to the third is really a perfect cube. 1 is also a perfect cube, and in this case I have the sum of two perfect cubes. Let's try example number 2. So let's multiply together 3x minus 2 times 9x squared plus 6x plus 4. So setting up my trinomial along the top, 9x squared, 6x, 4, and I have along the side 3x minus 2. So let's multiply 3x times 9x squared and get 27x to the third. 9x squared times negative 2 is negative 18x squared. 3x times 6x, that's 18x squared. 6x times negative 2, negative 12x. 3x times 4, positive 12x. 4 times negative 2, negative 8. So I see that my product has as its first term 27x to the third. The x squareds cancel, the x's cancel, and I have a negative 8. So clearly when my product has this special form that we see in this binomial times a trinomial, the product in this case turned out to be the difference of two perfect cubes. So when I am looking at the format of the sum of two cubes, a cubed plus b cubed, I'm going to be able to factor that into the binomial a plus b times the trinomial a squared minus ab plus b squared. Now here's a couple of things that are important to note. If I've got the sum of two cubes, that plus is always going to be the same sign as the binomial. But when I look at the trinomial, the sum of two cubes will always have in its trinomial the opposite sign in front of the second term. Likewise, if I'm trying to factor the difference of two cubes, a cubed minus b cubed, I'm going to see that the binomial is a minus b, and the trinomial is a squared plus ab plus b squared. So again, the sign between the two cubes is the same as the sign between the binomial factors, and the sign between the two cubes is the opposite of the sign inside the trinomial. Before we go on to a couple examples, let's remind ourselves of our perfect cubes that are going to be important to be able to recognize. So our perfect cubes begin with 1 to the third power. 1 to the third power we know to be 1. 2 to the third means 2 times 2 times 2, so that's 8. 3 to the third means 3 times 3 times 3, so that's 27. 4 to the third is 64. 5 to the third is 125. And 6 to the third gives me 216. That gives us a good list of perfect cubes that we can recognize. Obviously, there are others that we'll have to see in these examples as well. So when we look at the first example, we want to factor x cubed plus 8. We recognize that we have the sum of two perfect cubes. So I want to write this as my first term, x cubed, is really x to the third power. So I'm going to call that cube root a equals x. I want to write down what is being cubed. For the 8, that's going to be my b term. So b is equal to 2 because 2 is being cubed. Now, since I have the sum of two cubes, remember that your first factor is going to be exactly the same sign. So I'm going to say x plus 2. That's in the form of a plus b. My second factor is going to be the a squared. So I'm going to square the x and get x squared. Then I use the opposite sign, so I'm going to say a minus. Then I have to multiply the a times the b, so that's going to give me 2x. And then I have to square the b term, and that one is always positive, so I'm going to say plus 4. Now, just for the sake of proving to ourselves that this is actually the correct factors, let's go ahead and multiply this one out and see that I do get the correct product. So if I re-multiply this, I would have x squared minus 2x plus 4 multiplied by x plus 2. I'm hoping that the answer turns out to be x cubed plus 8. So x times x squared is x cubed. X squared times 2 is 2x squared. X times negative 2x is negative 2x squared. Negative 2x times 2 is negative 4x. 4 times x is 4x. 4 times 2 is positive 8. So looking at my diagonals, I see that the x squareds cancel, the x's cancel. So this product is just equal to x cubed plus 8. So that checks because that's exactly the binomial that I began with. So in factored form, that binomial is x plus 2 times x squared minus 2x plus 4. Now when I look at the trinomial, that's a trinomial that can never be factored. So I'm not going to be able to simplify this anymore or factor any further. Let's try the next example. I've got x cubed minus 1,000. So that tells me that my first term a is going to be x. That's the thing that's being cubed to give me my first term. My b is going to be equal to 10 because that's what's being cubed to give me 1,000. So for my factors, because I've got the difference of two cubes, my first factor will match that sign, so x minus 10. My second factor, I'm going to square the a term, so that's going to give me x squared. I'm going to take the opposite sign, so plus. I'm going to multiply the a and the b together, so that gives me 10x. And I'm going to square the b, and that part will always be positive, so plus 100. So my factors for x cubed minus 1,000 are x minus 10 times x squared plus 10x plus 100. And again, when I look at this trinomial cannot be factored any further. And if I were to do a distribution or a multiplication by the box method, I will get back to the answer x cubed minus 1,000. Let's take a look at example number 3 where we want to factor 8y cubed minus 27. So I'm going to write this as a is equal to 2y, b is equal to 3. So my factors are going to be 2y minus 3 times 4y squared plus 6y plus 9. Remember that the binomial factor will always match my difference of two cubes, and here in the trinomial I'll always have the opposite sign. Let's go to the next example. So we're going to say a is equal to 4x because I'm cubing 4x to get 64x cubed. B is equal to 1. So my factors are going to be 4x plus 1 multiplied by the 4x gets squared, so that's 16x squared. Opposite sign, so minus. 4x times 1 is 4x plus 1. Let's look at example number 5. Don't be intimidated by the fact that I have a fraction there. I'm not going to write this as a and b because the problem already has an a in it. So I'm just going to write down that the thing that's being cubed is 1/2 a. 729 is really 9 cubed. So there's my two terms. So going to my answer, I'm going to say my binomial factor will be 1/2 a plus 9. For my trinomial, let's square the 1/2 a. So that's 1/4 a squared. Opposite sign, so minus. Multiplying the a and the b together gives me 9/2 a. Squaring the 9 gives me plus 81. Let's do the last one together, number 6 here. But first of all, I notice that I don't have the difference of two perfect cubes. Instead, it looks like I have a GCF, first of all, in this problem. So I want to factor out the GCF of 2x. That leaves me with x to the third minus 125. And that definitely is a difference of two perfect cubes. So let's leave the 2x in front of my answer. My binomial factor will be x minus 5. My trinomial answer will be x squared plus 5x plus 25. So this is a really interesting example because I end up with a monomial times a binomial times a trinomial. And none of those can be factored any further, so I stop right there. It's completely factored. Now I'd like you to write down the you try it's and give them a try and then come back and check with my answers. So for you try it number 1, a cubed minus 216, I'm going to get the binomial a minus 6, and then the trinomial should be a squared plus 6a plus 36. To factor 27x cubed plus 64, that'll be 3x plus 4 times 9x squared minus 12x plus 16. So hopefully you've gotten an idea of how we're going to proceed with factoring the sum of two cubes or the difference of two cubes. So this is kind of a higher level factoring technique. So we'll be using it throughout this unit and actually throughout the whole course. Have a great night, and I'll see you in class where we'll practice some more of our factoring.